welcome to a new lecture on Industry 4.0. Today we will be discussing another core technology which is cloud computing and fog computing. These are actually integral parts of Industry 4.0 implementation. So before understanding what is cloud computing and fog computing, we have to understand what is computing. So as shown here, computing is the process of using computer technology to complete a given goal-oriented task. Computing may encompass the design and development of software and hardware systems for a broad range of purposes, often structuring, processing, and managing any kind of information to aid in the pursuit of scientific studies, making intelligent systems, and creating and using different media for entertainment and communication. So the use of a computer to process data or perform calculation is what is meant by computing. So it has scientific, engineering, mathematical, technological and social aspects. This list is actually virtually endless. So there is a kind of computing which is called the distributed computing, and this cloud computing, fog computing, these are all part of it. So let us learn what is this distributed computing. A distributed computer system consists of multiple software components that are on multiple computers, but actually it runs as a single system. The computers that are in a distributed system can be physically close together, and they could be connected by a local area network, or they can be geographically distant and connected by a wide area network, but they have to be connected. Then only distributed computing is possible. So a distributed system can consist of any number of possible configurations, such as mainframes, personal computers, workstations, mini computers, and so on. Even people have tried to do distributed computing using Raspberry Pi, which are simple single board computers. So the goal of distributed computing is to make such a network work as a single computer. So basically the network of computers will act like a single computer. That is what distributed computing means. So these are some computing systems, as you can see. One is a centralized computing system, the other is a decentralized computing system, and there is a distributed computing system. So we are basically interested in this distributed computing system. You can see here how the networks are actually connected in centralized, decentralized and distributed computing systems. So talking about this distributed system or distributed computing system, the goals are like this. To present a single system image, that means we have to hide the internal organization of the network, the communication details have to be hidden, and we have to provide a uniform interface. Then it should be easily expandable. That means we could easily add new computers to it. The number of computers is usually hidden from the users, and as and when the computing need arises, the network should be expandable. More nodes, more computing nodes could be added to the existing distributed system. Then continuous availability. So failures in one component can be covered by other component. That means if there is a hard drive that fails or a computing node fails, it should not affect the availability. The computing system will be always available. So there are important failure models that have been in use from a long time for normal cloud computers that are in use by many leading cloud service providers. So if a node fails there, that node has to be removed and another node has to be provided in place of it. There won't be any effect on the computing that is being performed by the distributed computing network. Then it should be supported by the middleware. Those are some of the important characteristics of distributed system. Now let us have a look on the advantages of distributed system over centralized system. So first important advantage is the speed. So when used to implement parallel processing, where our only goal is to achieve maximum speed on a single problem, distributed systems can achieve very high speed as compared to the centralized ones. Another important advantage is the inherent distribution. That means another reason for this building a distributed system is that some applications are inherently distributed. For example, if you want to do some banking operations, airline reservation, so there you can find multiple nodes are there from which these banking operations or ticket booking operations can be done. So these are all examples of applications that are inherently distributed. When all the branches of a bank are connected, we have a commercial distributed system. Some other advantages of these distributed systems over centralized systems are the reliability. In a normal computer, if the, let's say, the RAM fails or the CPU fails, the total computing resource fails. Whereas in distributed computers, by distributing the workload over many machines, a single chip failure will bring down at most one machine, leaving the rest of the machine intact. Now, for critical applications like nuclear reactors, aircraft, actually a distributed system can achieve high reliability and maybe a dominant consideration. Similarly, another important advantage is the incremental growth. So often a company will buy a mainframe with intention of doing all its work on it. But if the company grows, the workload increases, then mainframes are no longer adequate. They have to implement this distributed computing. Now that we have learned about the advantages of distributed system, let us learn about the some of the disadvantages. So major disadvantage is software. It is very difficult to develop software for distributed systems. Then control is another issue. Network is another issue. Sometimes if the network is the actual bottleneck, then it will just bring down the computing resource. So saturation of the network, lossy transmission can affect the computing. Then security is another major issue. Another issue is the hard to detect faults. Then administration issues could be also present in distributed computing systems. So now that we have learned about the distributed computing system, let us have a look on what is cluster computing. This is basically a kind of distributed computing, this cluster computing. So we'll have to look into it. So a computing cluster is basically a group of linked computers which are working together closely so that in many respects they form a single computer. So if you have some old computers, you can even make them work as a cluster. There will be a main node and then there will be the worker nodes. So the component of a cluster are commonly but not always connected to each other through fast local area net. Then clusters are usually deployed to improve performance and or availability over that provided by a single computer, while typically being much more cost effective than single computers of comparable speeds. So this is an example of implementation of a cluster. As you can see, multiple CPUs are there. Okay, they are all connected through the high speed local area network. Then there is a middleware layer on top of which you can run the applications. Now that we have learnt about cluster computing, let us discuss the advantages and disadvantages of it. Advantages are like increased speed. That means in comparison with a single computer, it can offer better performance. Optimized resources utilization. That means if you have a computing cluster, many users in your organization can use it. They can just provide their jobs there, computing jobs obviously, and they will be executed there. Then can execute large applications. If you have large applications that require huge computing power, they can easily run it. Disadvantages are complex programming models. That is actually the major issue. Difficult for debug and development. So it might be difficult to debug certain programs. Now that we have learned about the cluster computing, let us learn about grid computing. This is also a variety of the distributed computing. So these computing grids are conceptually and logically like electrical grids that we normally use for power distribution. So in electrical grid, the wall outlet allow us to connect to an infrastructure of resources which generate and distribute the electricity. So likewise, in the IT industry, grid computing uses middleware to coordinate distinct IT resources over the network, allowing them to function and work as a virtual whole. The goal of this computing grid, like that of electrical grid, is to provide users with the access to resources they need when they need them, and to provide remote access to IT assets and aggregating processing power. Grid provides a series of distributed computing resources via local area network or wide area network to the terminal user's application, as if he or she is using a super virtual computer. And the next category of computing is the cloud computing. So this cloud computing is a technology paradigm that involves the delivery of various computing services, including server, storage, databases, networking, software, and more over the internet. Instead of owning and maintaining physical hardware and software, cloud computing allows individuals and organizations also to access and use computing resources as a utility on a pay as you go basis. That means if you need storage, let's say 1 GB, you can pay this much amount of money. Let's say you want 10 GB, you need to pay this much. You need this many number of CPUs or this much amount of graphics, accordingly you pay. So let us have a look on the architecture of cloud computing, as you can see here. So here you can find that these are the end user devices like mobile, laptop, printer, desktop, etc. These are connected via gateway devices like routers, switches, etc. to the internet. Then through the internet they can access the cloud computing resources, which includes servers, virtual desktop, software platform, applications, storage for data. All these things are available. This is a simple architecture of cloud computing. So these are some of the characteristics of cloud computing, the top major characteristics. One is resources pooling. Lot of people can access these resources on demand also. So maintenance is easy. If a node fails, your cloud service provider will just replace it. You don't have to worry about it. So another important advantage of cloud computing is that it is scalable and it has rapid elasticity. So when there is demand, accordingly the computing resources can be provided, or more computing resources could be provided. So it is also economical, since many people will be using it and will be paying for it. You don't have to pay a large amount of money. Then measured and reporting service, security, automation, resiliency and availability, large network access, these are also some of the advantages. Now let us discuss the basic concepts of cloud computing. So there are certain services and models working behind the scene, making the cloud computing feasible and accessible to the end user. So there are two models basically, the deployment models, and there are the service model. So we have different types of cloud computing based on this kind of models. So based on this deployment, the cloud computing can be categorized into private, public, and hybrid clouds. Similarly, based on service model, it can be divided into infrastructure as a service, platform as a service, and software as a service. However, if you look into the deployment based cloud computing, there is another category also called the community cloud. That also we will discuss. So this diagram actually shows the additional community cloud. The first one is the public cloud. As you can see here, services are provided over the public internet and are available to anyone who wants to use them. Some of the examples are like AWS, Azure, and the Google Cloud. AWS is a service from Amazon, whereas Azure is a service from Microsoft, and Google is providing the Google Cloud. A public cloud is a type of cloud computing service that provides computing resources such as virtual machines, storage, database, and more over the internet to multiple customers or users on a shared infrastructure. These public cloud services are owned, operated, and maintained by third-party cloud providers, and they are made available to anyone who wants to use them. This is typically on a pay-as-you-go or subscription basis. So then there is the private cloud. So cloud resources are dedicated to a single organization and can be hosted on premises or by a third-party provider. They offer greater control and customization. So the private cloud is a cloud computing environment that is dedicated to a single organization or customer. providing the computing resources such as virtual machines. There can be storages also and networking on a private and isolated infrastructure. Unlike the public clouds, which are normally shared by multiple customers, a private cloud is designed for exclusive use by one entity. This cloud is actually prepared keeping the demands of that particular entity in mind. So, such as an enterprise, government agency, or a specific business unit in an organization can own a private cloud. Based on the combination of the good features of private and public cloud, we have the hybrid cloud. So this hybrid cloud, as we discussed, combines both public and private cloud resources, allowing data and applications to be shared between them. This offers flexibility and scalability while maintaining security and control. The hybrid cloud is a cloud computing environment that combines elements of both public cloud and private cloud solutions, allowing the data and applications to be shared between them. In a hybrid cloud, these two cloud models are connected and operated as a single unified computing environment. This architecture provides greater flexibility, scalability, and efficiency while maintaining a balance between the control and cost effectiveness. So the clouds that exist nowadays, the Google Cloud or the Amazon Web Services or the Cisco Cloud, these are all based on the hybrid mechanism, a combination of public and private cloud. So this slide shows you a lot of these hybrid cloud providers. Next is the community cloud. A community cloud is a specific type of cloud computing deployment model that is designed to serve the computing needs of multiple organizations, typically with shared interest, such as common regulatory requirements, security concerns, or let's say industry specific compliance standards. So in a community cloud, these organizations come together to share computing resources, infrastructure, and services while maintaining a degree of isolation and control over their data and applications. So let's say few manufacturers are there, they will just form a community and they might be sharing the common requirements, or they can design a cloud for their own use. So that kind of cloud could be called as a community cloud. So now based on service models, the cloud can be specified into multiple types. First one is the infrastructure as a service. So infrastructure as service provides access to fundamental resources such as physical machines, virtual storage, etc. Similarly, there is another category which is platform as service. So it provides the runtime environment for application development and also deployment tools. Similarly, in software as a service, this model allows to use software applications as a service to end users. For example, the Adobe Photoshop, you can use it as a software as service. So here we can see the different cloud models. When we discuss about the on-premises, it means all the applications like networking, storage, servers, all the hardware and software are on the premises of the company. Okay, the user is actually maintaining everything. Similarly, when we discuss about infrastructure as a service, you can see networking, storage, servers, virtualizations, these are managed by the cloud service provider, whereas you see applications, data, runtime, middleware, OS, these are all managed by the user. Similarly, when we discuss about platform as a service, you can see the green portions, the runtime, middleware, OS, all these things apart from the ones that were covered in infrastructure as service are all managed by this cloud service provider, whereas applications and data are only managed by the user. And when we discuss about software as a service, everything is actually managed by the cloud service provider. User has to just use the resources. Let us now look at the different characteristics of a cloud. The first and the most important characteristics of the cloud is the on-demand self-services. So there are computer services such as email, applications, network and server service, and this can be provided without requiring human interaction with each service provider. So cloud service providers providing on-demand self-services include the Amazon Web Services, Microsoft, Google, IBM, Salesforce.com. These are some of the examples. Then the second one characteristic, let me repeat it. Then the second characteristic is the broad network access. So cloud capabilities are available over the network, and these are accessed through standard mechanisms that promote use of heterogeneous thin and thick client platforms such as mobile phones, laptops and PDAs can be used to access these services. Then the third important characteristic of the cloud is the resource pooling. This is the major advantage actually. The provider's computing resources are pooled together to serve multiple consumers using the multiple tenant model with different physical and virtual resources dynamically assigned and reassigned according to consumer demand. That is what actually brings down the cost, right? Let me repeat it. The resources include storage, processing, memory, network, bandwidth, virtual machines, and email service. Another important characteristic of the cloud is the rapid elasticity. Now, these cloud services can be rapidly and elastically provisioned, in some cases automatically, to quickly scale out and rapidly release to quickly scale in. Like in this case, as you can see, this is the time axis and this is the visitor axis. Let's say there is a kind of service that you have launched, and that is you have deployed it on the cloud. Let us say that you have deployed it on the cloud. Now, let's say the number of visitors was low here. Suddenly the number of users increased or the visitors increased. So if you have your own computing resources, it might be difficult for you to scale the resources. So what would happen? That would result in, as the number of visitors obviously increase, that would result in denial of service. But if it is implemented on the cloud, since cloud has rapid elasticity, it can provide more resources to you, and accordingly you can serve the higher amount of users. That is what I mean when I say that the cloud can quickly scale out and rapidly release to quickly scale in. So to the consumer, the capabilities available for provisioning often appear to be unlimited and can be purchased in any quantity at any time. So whatever resources you need, you can purchase them according to the demand. Now let us have a look on the benefits of the cloud. The benefits of cloud include it reduces the operational issues, increases the team collaboration. It also saves you money because you are pooling the resources. Otherwise, if you maintain the resources yourself, it would cost more money. So the cloud improves security. Cloud is sustainable also. Next is the disadvantages of cloud computing. Security issues might still be prevalent. That is one of the major issues. Management issues can be there. Lack of expertise is another issue. Performance issues could be there, and sometimes migration issues could. Let's say you are using the services of one cloud service provider and you would like to migrate to some other cloud service provider, then this migration might not be easy. Okay, so now let us discuss another kind of distributed computing, which is the fog computing. However, before discussing like the fog computing, we have to understand why would we use the fog computing. Actually, there are a number of issues in the cloud computing for which we have to move to something like the fog computing. The major issue is latency. So if there is something that requires real-time interaction, the cloud may not be the place to go. So video streaming, gaming, augmented reality are some of the examples. Then another issue is the geographical distribution. So widely distributed deployments. So for massively multiplayer online games, this clouds can be an issue. Sometimes route planning in traffic planning, those are the cases this could be an issue. Then mobile deployment. When the nodes will be moving in such a case, such as we have the cell phones, vehicles, so in such cases it is difficult to use cloud computing. Another issue is the large number of nodes. Okay, when you have sensor nodes, okay, or the network of sensors that we have in the case of IoT or Internet of Things, then the cloud may not serve our purpose and we have to go for the fog computing. So this fog platform provides low latency virtualized services and is linked to the cloud computing infrastructure. So as you can see, we have these end devices here. Okay, they are connected through a network, and here you can see there is the cloud computing. So between the cloud computing infrastructure and the end user, you can find the fog computing. So this fog computing platform provides low latency virtualized services and is linked to the cloud computing infrastructure. So these edge devices request computing, storage and communication services from the fog. So devices which will be actually accessing the fog computing resources are called the edge devices. Okay, so edge devices can request for compute, storage and communication services from the fog. So the fog provides local low latency response to this request and forwards relevant data for computationally intensive processing. So if there is a minimal computing requirement, obviously this computing requirement will be much higher compared to what one end user can device can actually process. So that will be provided to a fog computing environment for processing. But in case the computing required is more intensive, computationally more intensive, it can be then forwarded to the cloud. Now the question is where this fog computing can be used. So as you can see here in this example, smart city, manufacturing and construction, mining, agriculture, tech, energy, healthcare, transportation and logistics, consumer IoT, all these can benefit from fog computing. Now let us have a look on the characteristics of fog computing. So some of the major characteristics are like low latency, which can be quite useful for video delivery, navigational information. Another important characteristic of fog computing is location awareness. So traffic lights, navigation, sensor networks, they use of this feature of local awareness. Then widespread geographical distribution. So nodes can be located anywhere. This fog computing can be used anywhere. Another characteristic of fog computing is mobility. That means fitness trackers, phones and vehicles can use it. So while you are mobile, you can actually use the fog computing resources. Now let us have a look on some of the pros and cons of fog computing. So some of the pros are like this: reduces the amount of data to be sent to the cloud because fog processes it, conserves network bandwidth, similarly improves system response time. Then in some cases it can improve security by keeping data close to the edge. So you're not sending the data to the cloud and it is residing in the edge itself. Then supports mobility. This is one of the major advantages. Minimizes network and internet latency. Similarly, if we look at the cons, the physical locations take away from any time, anywhere, any data benefit of the cloud. Security issues such as IP address spoofing, man-in-middle attacks, this could be some issues. Privacy issues could be there. Then availability and cost of log equipment, hardware, these are all the issues. Trust and authentication concerns, because a lot of nodes will be joining the fog, they will be leaving the fog. So here the user might not be aware of the nodes which will be joining the fog and will be assisting him or her in computation. Wireless network security concerns are also there because the nodes are mobile and only wireless communication can support the communication here. So this is all about the fog computing and the cloud computing. Let us end the class here. Let us meet in the next class.